Sir, we are live now. We can start.
Sure, I'll stop my video and I'll share my presentation once again. So just once last check if you can share it, if you can see it in full screen and
Yes, sir. We can
hear
see it
me
on.
well. Okay, thank you. So good evening all and thank you for this opportunity. My name is Abhimanyu Singh and I'm Senior Technology Specialist at Ansys and I lead the technical activities of Ansys India Academic Program. I have been associated with Ansys for over 3 years now with 13 plus years of industrial experience. I feel privileged to be working directly with academic community, which includes leading research institutes, professors, governing bodies, and student community at large. I welcome you all for this session where I'll not only talk about this workshop, but I'll also provide you a brief overview of ANSYS and ANSYS academic program. So in the next 30 minutes or so, this will be the agenda of my talk. First, I'll start with a brief introduction to ANSYS. Then we look into the challenges and drivers in industry as well as in higher education market. We'll talk about future skills from one industry perspective, which can be extrapolated to other industries. Then I'll talk about ANSYS academic program and also about this workshop, what to expect. Last but not the least, I'll cover the important enablement tools in learning resources. So let me introduce ANSYS briefly, who we are and what we do. Founded in 1970, we have been in simulation industry for over 50 years now, with offices spread across 85 locations, 4,800 plus employees, and 150 plus channel partners globally. We are into engineering simulations and focused at what we do, with a market cap of $32 billion and a proven track record. Ansys is also a member of prestigious S&P and NASDAQ 100 index. Our overall customer satisfaction stands at 89% globally as per 2020 data, but we continue to scale that further. Now, Ansys enables you to predict with confidence that your product will thrive in the real world. Industry leaders use Ansys to create complete virtual prototype of complex products and systems, comprises of mechanical, electronics, and embedded software components, which incorporates all the physical phenomena that exist in real world. So these are some of the world-class companies leveraging our platform. Ansys was formed about 50 years ago with a core mechanical and structural analysis solver by solving second-order partial differential equations called Euler equation using finite element method, and subsequently we acquired the ability to solve fluid dynamics problem by solving Navier-Stokes equation. Then we acquired the ability to solve electromagnetics problem by solving Maxwell's equation. So over the years we have acquired the ability to provide the best of breed individual physics solvers for our customers. Now while we continue to innovate in each of these solvers every year, but in recent years we have enabled users to solve multi-physics interaction by integrating these solvers on a single platform using various solver coupling techniques. We acquired Granta, which allowed us to provide a material intelligence platform. This platform allows us to integrate more than hundreds of thousands of material properties to drive the detailed simulation. So Ansys offers the only true simulation platform with best of breed individual simulation tools across all major physics and allowing customers to innovate and make meaningful contributions to various mega trends that we see today: 5G, electrification, autonomy, IIoT, healthcare, and much more. Now, as the digital and physical world becomes one, the products are also growing in complexity. Now, companies are facing unrelenting pressures to innovate, lower cycle times, and reduce costs, while also increasing quality and eliminating risk. So, simulation is becoming pervasive within the entire engineering enterprise, from digital exploration to digital designing, digital prototyping to digital twin. So, ANSYS gives you the tool to tackle the complexity of designing, manufacturing, and maintaining your product and processes. So you can expand your simulation activities throughout your product development cycle, from design validated to exploring the what ifs of your product, facilitating innovations, lowering development and operational cost, and improving time to market. Now let's look at some of the challenges and drivers. So what are the challenges and drivers in reshaping the higher education? But before we go there, let's understand what are the key disruptions happening in industrial space, which directly impact the jobs that are available today and also help us understand the future skills needed for the jobs in future. So what are the key disruptions or innovations in this space? Automotive is definitely going through some major disruptions, but the technology advancements are also going to be crucial element in various other industry segments. Electrification continues to be number one spot with a lot of support coming in from the government. We are seeing significant traction in the design and development and associated research of electrified fuel cell and hybrid systems. In autonomous system, ADAS system finds more relevance from the safety point of view. You see a lot of autonomy and features being bundled in a modern car today, such as lane assist control, cruise control, automated emergency braking, and so on. Simulation is definitely one of the most crucial element in realizing the dream of full autonomous vehicle where we are talking about level 4 and 5. From the serviceability point of view, there is a growing interest in collecting data from operating vehicles for predictive maintenance. This will gain even more importance for commercial vehicles where downtime can have even a bigger impact on the fleet performance. This is powered by advancement in next generation communication systems such as 5G and 6G. Last but not the least, advanced material and new manufacturing processes. So if you look at the product innovations today, nearly 70% are related to development of new materials or the combination of existing material in a different manner. So there is a growing interest in the age of electrified, connected and autonomous system for developing new materials and manufacturing processes for various aspects such as weight reduction, cost reduction or part elimination. So what are the three demands which is reshaping the higher education market? If you talk about industry, they want good talent of engineers to lead innovation that is needed to thrive. Students want better employment opportunity. And if you talk of government perspective, we want more competent workforce with skills needed for future engineers. So these are helping propel a wave of students seeking additional qualification beyond the first degree. So this is one survey done by Gallup Strata to understand what students are requiring and what employers require. So students want to be successful in the job market. They want to get a job. They want to be successful in the workplace. An employer wants this student coming out of college to be really proficient that is needed for the job. We know there is a skill gap. So essentially the inability to apply the theory and concept that you learn in curriculum directly in the industry. So if you see this survey result, it tells you that approximately two-thirds of the students coming out of college do not feel confident of being successful in the job market. And only 35% students feel confident to be successful in workplace. And if you also look at employer survey result, they feel only 42% are employable or workforce ready. So this also necessitates the need to impart skill-based knowledge, focused training, devising a scalable solution that can be open for everyone. So this is also one of the mega trend that we observed in the future of engineering education. Here I'm going to take an example of automotive engineering where we are seeing some major disruption. We talk about this autonomous, connected, electrified system and shared mobility system. So the observation are also going to be valid for many other disciplines. I'm going to extensively quote an excerpt from a white paper, Mobility Engineer 2030. This is a collaborative initiative led by FISITA with contributions coming from FISITA corporate members, FISITA Technical and Education Committee, and Academic Advisory Board. This essentially talks about necessary skills needed for future mobility engineers and the skills needed to make students more employable and workforce ready. So if you look at the automotive industry, how the automotive industry is changing, there are three major revolutions which are reshaping the automotive industry. This is represented by the corners of the triangle that you see here. First one is energy revolution, second is intelligence revolution, and third is the connectivity revolution. We are all aware of the connectivity revolution, which basically talks about smartphone, smart devices, and the range of power the connectivity brings in with the ecosystem of telco technologies. When we talk about intelligence revolution, we are talking about use of data analytics, artificial intelligence, and machine learning for decision making and to make the system more efficient. Finally, if energy revolution is about tapping renewable energy such as solar, wind, tidal, and so on, and the impact it can create in automotive technology. Now, in the next phase, we are seeing these three revolutions are coming in together to reshape the automotive industry. And if you were to ask what impact it has made so far, you can look at the 6 gray blocks. It talks about the influence the revolution has caused. First block on the left states that due to the evolution of connectivity, the information which was in silos are enabling the vehicle to become an intelligent terminal. Then in the past and current state, we have humans driving the vehicle, and in the future you will see fully autonomous vehicle. Then in the future, you will also see car as a source of energy and or mobile energy, which was being seen as energy dissipation device. Similarly, if you look at the right side, we are talking about sharing a car instead of a notion of owning a car, which would essentially enable you to have a vehicle access on the need basis. Next is manufacturing, which has evolved significantly. So we talked about additive manufacturing. So we talk about Industry 4.0, digital manufacturing, and so on, which is becoming connected and intelligent. And lastly, vehicle will, which was looked as a tool for movement only, is also being used as a transportation service. If you look at the bottom blocks, we are going to witness a new development methods, new manufacturing methods, new core technologies, new maintenance methods, and even new architecture. So essentially, we are talking about transformation from new automotive product to new mobility ecosystem in future, which would largely be impacted by major disruptions in the automotive industry, such as electric traction, automated driving, connected cars, and mobility on demand. So this also necessitates the reshaping educational concept, and academia has a key role to play here. So I'm going to cover this again from automotive perspective. So the feedback from Visita corporate members shows that the traditional science, technology, engineering, and mathematics, which we also call STEM skills, will remain an important part of the skill mix. So the classical automotive engineer with profound knowledge in mechanical engineering, mechatronics, and material will still be necessary. However, in the context of electrified, connected, autonomous, and shared mobility, the qualification profile of a universal engineer with a deeper knowledge of other engineering discipline will gain increase in importance. So in general terms, companies anticipate a shift in requirement from a pure mechanical engineer profile towards a mixture of mechanical and electronics or mechanical and software engineer profile. So how do you acquire these skills? The one circled in the purple color are the skills you pick up when you are in college, and the one in the gold color are the skills you acquire when you join industry. Of course, there is an overlap of areas where you pick up skills both in industry and in college, and this is how we need to reshape the educational concept to make student workplace ready. So how do we do it? Basically, you get internship, you work with industry mentors, participate in advanced student competition, and this also holds true when you're in industry because you need to continue to upskill yourself. So Ansys is also investing in the talent development for future. On the field, we are engaged at 3,300 universities across 91 countries who are leveraging Ansys for teaching and research. Granta or a tool for material education alone is being used at 1,500 plus universities. Now around July 2020, we launched Ansys Innovation Courses, which has seen more than 319,000 plus unique users with India comprising of majority of the traffic. This has also established our belief in the need of reshaping engineering education in India. We have seen more than 2.14 million plus free student product download spanning 148 countries and also 1.12 million plus unique user visiting our platform Ansys Learning Forum, which is a collaborative learning and technical support platform. So we are also partnering in this endeavor with several key anchor universities to develop these courses, which can be made available to all. So what are the benefits of Ansys academic program? We have an academic program in place with a clear vision and goal of helping students succeed. Leveraging Ansys academic program, there are some of the ways by which we interact with academia, namely curriculum enhancement, support to student competition, capstone project, research grant, and also to boost research. Our broader goals are to inspire, so every student must know simulation is the key of their career, to train students in simulation, and also to boost student career by creating an ecosystem where we can connect student to companies looking for simulation trained engineers. So where is Ansys being used in engineering? Excuse me. Ansys offers industry leading tools in the areas of computational fluid dynamics, finite element analysis, computational electromagnetics, optical, embedded, and so on. And the most important aspect is the ability to perform multi-physics simulation. Ansys finds strong root in many engineering disciplines such as mechanical, aerospace, chemical engineering, civil, electrical, electronics. But over the last few years, we have seen an increase of Ansys usage in various new departments such as physics, biomedical, and various interdisciplinary departments. So you can say Ansys is pervasive across various engineering disciplines. Now coming to this workshop. Now again, I would like to reiterate that it is our privilege to partner with NPTEL in the enablement of academic community especially future engineers. Now, we share a common vision and synergy in making high quality education available to all. Through this workshop and a series of similar enablement in future, we aim to upskill student and faculty members with the necessary skill set and know-how on engineering simulation. So let's look at the structure of this workshop first. So in this first series, as I would call it, we are conducting a total of 5 sessions, which are on Saturdays from 10 a.m. to 12:30 p.m. So essentially 2.5 hours. This would include introduction to the topic, various modeling techniques, the state-of-art modeling methodologies that we employ. We'll also talk about the capabilities and the relevant industry examples. This will be followed by a brief demo and also a hands-on workshop. So for hands-on workshop, we'll share the practice problems with you, which you can follow along with us when we run the session. So through this session, we aim to provide fundamental understanding to various computational methods such as CFD, FEA, low frequency and high frequency electromagnetic simulation. And we have also added a topic on design for additive manufacturing. So with this, I would like to also invite you to register for this session and upskill yourself. And more importantly, I would also urge you to provide us with the feedback on the planned session, as well as what else you would like to see in future sessions, such as topics, application areas, and so on, so that we can also plan that. Now, in the next few minutes, I'll cover some important building blocks for continuous learning. First one is Ansys student product. So in order to equip students with necessary tools to learn new technologies, we have various Ansys student products. Students can download this on their personal laptop and start learning. We have Ansys Discovery, which is based on instantaneous simulation technology. Then in Ansys Student, we have Ansys Mechanical and Ansys CFD, along with other tools, which remains most popular amongst the student. Recently, we added Ansys LS-DYNA for explicit dynamic simulation, such as crash analysis or high deformation analysis. Then we added Ansys CADE, where you can do model-based design, you can do automated code generation for mission critical application. The latest one in the offering is Ansys Electronic Desktop, which was a long pending ask from academic community. And this bundle comprises of various tools such as Ansys Maxwell for electric machine simulation, Ansys HFSS, where you can do antenna design. Then we have Ansys IcePack for electronic thermal management, and also Ansys Q3D. Second important element in learning resources is Ansys Innovation Courses. They are online self-paced physics and engineering courses designed for engineers, students, and educators to deepen their understanding of the selected subject, and also helps in reinforcing relevant concept using Ansys simulation environment. So students and early career engineers can take these courses to enhance their skills, and also educators can assign these courses for homework within their curriculum. These online lectures videos, which are led by Ansys experts and key academic partners in addition to the homework, tutorials and quizzes, provides a comprehensive educational experience. So they are based on a MOOC anatomy, where you have video bites to give you the fundamental concepts, followed by simulation example. So what additional element we bring in, we provide you with the case and data file on those pages which you can download. Then you have a step-by-step tutorials to follow, and you can practice alongside. Some of the statistics on Ansys Innovation Courses: we have 200 plus free AIC courses hosted on our website. They cover various disciplines such as fluids, structures, electronics, STEM, and we have also added recently various courses on materials and photonics. So I would encourage you to visit the website www.courses.ansys.com if you haven't already, and you can start learning. Now, another important piece is the technical support to student and faculty members who are using Ansys for teaching or research or simulation projects. So how do you seek support? So Ansys Learning Forum is a go-to place for students, educators, researchers, and industry engineers to engage with peers and Ansys experts. You can discuss simulation, you can discuss installation and licensing related issues, you can discuss basically physics or even the Ansys innovation courses that you're taking. So on the forum, you have various methods of engagement. You can engage with peer-to-peer and also with Ansys expert. You can browse through various queries that are already there. So we have thousands of queries subgrouped into various different topics. And you can also view various tutorials. We have a specific section for student competition. So if you're a student working with any student competition, you can refer to this section, and find the relevant tutorials. And with that, I'll come to the last element, which is Ansys Learning Hub, which is a named user subscription. So if you're looking to upskill or improve your skills or to maximize your productivity, or also to need the right solution, Ansys Learning Hub is the answer, ALH as we call it. It is a learning management system and a centralized knowledge portal that offers rich learning experience and continuous learning experience across the portfolio. This is targeted towards professional courses and serves as a one-stop solution for learning where you gain unlimited access to a wealth of resources, which includes globally scheduled classroom courses, virtual courses in all time zone, self-paced video courses, learning path to guide your course selection, and also continuous learning support from Ansys expert within the hub. You also have best practices guides and demo videos, training materials, and also access to latest curriculum update and new courses. So as we keep developing the content, currently we have 240 plus courses, including 1000 plus workshops, 240 plus hours of recorded video modules for self-paced learning, and also 45 plus learning rooms for collaborative learning with special section of learn from the expert. It gives you access to 300 plus virtual classes per year, and also post pandemic you will gain access to 200 plus in center classes per year. So in Learning Hub, we also have something called role-based learning. So if you are aspiring to be a thermal engineer or aeroacoustic engineer, aerodynamics engineer, or even FE engineers, we provide you a curated learning path for each of these roles, which given by say core courses, foundation courses, as well as the elective courses, which you can take and gain proficiency in those disciplines. So with that, I have come to the last part where I'll play a small video. Let me see if the sound is enabled or if I need to re-enable the sound. Can you confirm if you are able to hear it? Okay, let me reshare with the sound.
Engineering is about building things. Things that move us all forward, that bring us together. But the landscape is changing fast. New technologies are rapidly advancing, and universities must respond. Engineering will always be about building things. But if you want to build a career in engineering today, simulation is the future, and Ansys is leading the way. No longer a sophisticated tool of the most experienced engineers, simulation is becoming pervasive in engineering departments around the world. Universities everywhere are also embracing this new reality, partnering with Ansys to bring more powerful simulation solutions into their curriculums, empowering engineering students with the very same product design software they will soon be using in the real world. Much more than a practical teaching tool, simulation is becoming an imperative skill for young engineers, giving students a clear advantage in pursuing the most promising careers. And the future does indeed look promising. For students looking to build a career in engineering, you've come to the right place. Careers begin with learning Ansys.
Yeah, so thank you for your attention and patience. And I know I have finished a few minutes early, but I would be happy to stay if there are any questions related to this workshop. With that, let me stop sharing. And sir, could you let us know how to access to these questions or comments if there are any? Okay, so I'm going through some of the questions on the YouTube. Yes, since this is live streamed on YouTube, this video will be available on the same channel link that you're watching it on. There is a question, no learning course is free for student. The Ansys Innovation courses that I shared earlier. So you can visit courses.ansys.com and you'll be happy to locate that more than 200 plus courses are free to access. And I'll also share the link in the same chat on YouTube. Will these courses on Ansys website help to get a job based on simulation? So definitely these courses are going to make you more employable because simulation, as we understand, is the key enabler to your career, and it will definitely help you make informed decision not only in your career choices but also if you are pursuing higher education. What is the computer specification to download Ansys? So if you go to Ansys student product, in each of these sections you will see minimum requirement highlighted there, so you can refer to those minimum requirement because it depends also on the tools that you are downloading. Will the workshop sessions be recorded? Yes, we'll also record the workshop. The people who are registering will have access to those recordings. And along with that, as I said earlier, we'll also be sharing the workshop files and the associated tutorials that we'll cover in hands-on demo. Please tell us what is the prerequisite for this course. So there is no particular prerequisite for this course. If you want to practice alongside, I'd request you to visit Ansys student page and download Ansys on your personal computer or the laptop, as I say, and so that you can also follow along the demo and the practice sessions. Where can we register for the courses? So you should have received a communication from NPTEL, but if there is any additional links, sir, can you help me with that so that I can paste it in YouTube channel? Yes, the workshop is virtual and online. So we are doing it on every Saturday with one Saturday gap when we have an NPTEL exam. So starting 12th of March, every Saturday, 2.5 hour sessions, starting 10 a.m. to 12:30 p.m. There are more questions on registration. So may I request sir to give me a link which I can paste in that chatter so that it could benefit others. To what level will the course content be? So typically, even if you're a second year undergrad or first year and would want to pick relevant electives, if you're a first year student, you can still pick this. You can still go through this workshop so you would understand the power of simulation and what promises it holds in your career. And accordingly, you can make informed decisions of your electives that you're going to pick in future semesters. Are there any courses for freshers who have just recently joined the industry? Yes, many of these courses, if you see, they complement the curriculum. So through Ansys Innovation courses, our endeavor is not to replace a curriculum, but basically complementing what you're already going through or learning in the curriculum. So they will help you in solving some relevant contextual example. And so we are using an industry specific problems and examples which will help you reinforce your learnings, what you have studied in your college. So you need to register once for this workshop and you should be able to get meeting links from NPTEL. There is a question. I have taken basic course in fluid mechanics and solid mechanics. Can I study Ansys right now before taking specialized courses in CFD or FEM? Yes, but I would still suggest that since you are working on the CFD and various numerical technique or FEM, so it would be advisable that you also go through the coursework, because what is more important is also to build foundation and understand what is happening behind the hood in these tools, because we are using numerical techniques. So you'll appreciate it more once you go through those courses. For workshop, anything we have to install? Yes, if you want to follow along the tutorials and demo, then I would request you to download the Ansys student products. How we will get access to Learning Hub. So these are named user subscription. So basically access to professional courses. So they are not free courses. So if you want to learn more, you can reach out to us. We'll be happy to help you with the details. A question on will you be teaching from scratch, because I don't have any basic knowledge of from Ansys. So yes, it will be a foundational course where you will appreciate how to set up, say, finite element analysis problem or computational fluid dynamics problem. And even if you don't have any background of Ansys, you'll be able to pick it up. Do we get any Ansys certification level certificate with this? No, this is not a certification course because that need to be more involved, but you need to stay tuned because we have certification model coming up. Maxwell course detail, please. So we have a workshop on low frequency electromagnetic where we will be covering Ansys Maxwell, and you will be able to learn and appreciate how to design electric machine using Ansys Maxwell, followed by demo as well as tutorial. Yes, there is a nominal fee for all the workshop, so you could see those details on NPTEL website. Okay, there are more questions coming in. I'll maybe skim through some of the questions. So during these sessions, what I will do is I'll also share some of the recorded trainings which were earlier conducted in different time zone for different academic community, which will also help you pick those concepts. Say, for example, we did few back to school webinar series. So in those we had followed similar format of going through the introduction and then a hands-on demo. So there you can definitely refer to those recordings because I see a lot of questions on how to access recording and where all they can find additional resources. And in reference to this workshop, which is upcoming this Saturday, we'll definitely record it and share it with the registered participants. So we are already a couple of minutes on top of the hour, sir. So I think we may have to close this. There are more questions coming in, but I'll stay tuned on those channels and try to respond to a few questions. So there are many questions related to technical support and some questions related to problem statement you are working in. So that is where the third element I covered, Ansys Learning Forum. I'd request you to visit www.forum.ansys.com, and you'll be surprised to see that your peers across the globe may have asked those questions. You can also register and post a new query, and your peer as well as an Ansys expert would be happy to help you there. Yeah, about Ansys student products. So there are numerical problem size limit on student versions, which the first thing is it needs to be installed on your personal laptop. And each physics, say for example, FEA has a different numerical limit, CFD has a different numerical limit, and so it goes for low frequency and high frequency electromagnetic. But those limits are fair enough for student to pick up concept and learn those concepts which they can use to. So there is a very interesting question: is class 12 student join these courses? Okay, so somebody is in class 12 and wanted to join. So yes, I would say that STEM courses starts from class 12th onwards. So if you're really interested in making career choices related to any of the core engineering discipline, then I would urge you to attend these workshops, learn more about what we do and how we impact the careers, as well as how it will help you make informed decisions. So with those, uh, with keeping that in mind, you can join these courses. Okay, so I think we can close this session now, because we are already 5 minutes on top of the hour. But if there are any more follow-up questions, I'll take that on YouTube channel. Last question I'll take, sir, on the certificate participation. Yes, you will receive a participation certificate from NPTEL. So if you register for this workshop, we'll also be providing you a participation certificate. Yes, sir. So we can stop the streaming, and can we close this session? I think you may have to close this.